All right, the work of investigation of strain using rock fabrics began with petrographic thin sections and features at the mineral scale in mostly polycrystalline rock. So there's heterogeneous materials that all deform in the way that suits the crystallography and the chemical makeup of the rocks with influences of temperature, pressure, and fluids. Today's plan is to go ahead and work at a few rocks and introduce two things working with hand samples: the geometrical elements for structural analysis of deformed mid-crustal rocks. So those rocks are going to be gneisses of some description for the purpose of conversation today. What are the planar fabrics that are measurable with a Brunton compass? What are the linear fabrics that are measurable with a Brunton compass? We'll go through a series of about 10 hand samples to show this. Now, what are the planar fabrics in a specimen like this that if you look at it really loosely, it looks like, okay, well, that's maybe a slate. I could use it for a paving stone in my garden. But if we look more closely, this really thin piece that is broken upon extremely regular planes is also ornamented with a linear fabric defined by quartz and biotite that we can see on the surface of those planes. The planes are foliation, the lines are lineation. So those are our two fabrics that we will seek, and they're physical things that we can put our hands on, see in outcrops, and measure with a compass. So foliation, lineation, or we can flexibly use the word striae or striations for those lines, but these are specifically not slicken lines formed by frictional grinding and scraping. These are lines formed by recrystallization and growth of minerals in the least direction, in the stretching direction where there's the least opposition to their growth. Okay, then while we're on this page, I'm going to also insert conceptual planes, one of which was introduced yesterday, the motion plane. And I'd like you to think about, based on comparison with brittle faults, how is the motion plane positioned with respect to deformed rocks? Also lines, and those are principally going to be poles to planes. In addition to the motion plane, we'll be interested in the profile plane and some principal planes that you well understand based on the treatment of stress, that principal planes have special role as a sort of a coordinate system of reference surfaces. Okay, so let's look at a number of rock samples that I have here. And all of these would fall in the general class of gneisses as opposed to schist or slates. The first one that I'd like to show, let's show 3 pairs of dark rocks. Okay, so here's a rock that has a sparkly surface, and that upper surface looks extremely planar. If I turn it over, the bottom surface, less sparkly because there's oxidation on it from it being buried underground, that's also planar. If I look at the profile, the upper and lower contacts are very similar. Okay, the upper surface has a pattern that suggests a streaky down dip direction in the way that I'm holding this. This is a meta-amphibolite from the Snake Range in Nevada.